Welcome to part 9 of Senior Developer in 24 Hours. Today we're going to continue to talk about keeping the team productive. Now, let's do a quick recap of what we were talking about last week. Let's keep in mind that software is very complicated nowadays. And because it is very complicated, we have to coordinate with a lot of other teams to be able to have access to dependencies, to get infrastructure permission, to make sure that all of the external elements that our application depends on are ready. And it is also really important to note that good design will shed light on these dependencies so that we can manage those dependencies by mostly working around roadblocks that we're going to encounter as we try to implement our application. Because, I mean, our team can write as much code, but there's only so much we can do to coordinate with other teams for those teams to provide the services, the dependencies, the APIs, the infrastructure that we depend on. With that said, today we're going to be talking about how do we actually get around those roadblocks. And we're going to talk about this in 5 discrete steps. The first one is obviously identifying the external dependencies. And we talked a lot about this last week, so if you want more detail, you can watch last week's video. But yeah, obviously, before we can work around any possible dependencies that could cause a roadblock in our progress, we need to identify them. So what are we talking about this? Well, first thing is that identifying these dependencies should have been done as part of the design. The sooner we do it, the better. Once we have identified them, we can start looking which ones are ready and already meet the requirements that we have. And for the ones that are missing, what does the timeline look like and how worried should we be? How much of a risk are those dependencies to the success of our project? Now, we have identified those dependencies. How do we work around them? And now we're going to start talking about the different strategies to be able to work around some of those dependencies that might not be ready. Okay, so first thing, emulators. When can we use emulators? Emulators work really well when we are talking about depending on off-the-shelf components. This is normally infrastructure components that haven't been provisioned for us. Or sometimes we need to use emulators because we need to be able to run disconnected. Sometimes, we might have some infrastructure set up for us, but multi-tenancy is not completely viable. So we have to find a way to allow multiple developers to be able to work independently with limited set of infrastructure components. Okay, what is an emulator? In the very strict sense, an emulator is a hardware device or a software program that imitates the behavior of another program or device. But in the practical sense, it is basically, for what we're talking about, for our context, it is a local instance of an external service we depend on. And it is a software program that imitates another program or a service. But it can also be a library that allows us to start a service inside of our own process. Okay, so here are some of the examples of emulators and how they can be used during development. For example, we can use a local instance of a database or other off-the-shelf component. If you can install it locally, you can run it. To make it easier for your teammates to be able to run this, if you can run it in a container, much better. It is a lot easier to distribute, for example, a Docker Compose file or a dev container configuration so that your teammates can replicate the emulators that they need to run locally without having to manually go through all of the installation and all of the management. With that said, there are some issues with local instances as emulators. In particular, there is normally limited functionality, mostly when we're talking about things like very high, uh, very high performance operations, data replication, things like that. Sometimes we cannot fully replicate the functionality of the actual infrastructure component, the actual database or the actual message queue or things like that. But they do provide a very close approximation, at least to be able to write our code against something that provides a similar or equivalent interface. Performance will not match actual service, which can be really tricky if we're dealing with performance issues, if we're dealing with optimizations, things like that. And finally, local resources can be quickly exhausted if you have to start up, multiple databases, multiple different services. There's only so much RAM you have in your local computer, in your local development laptop. So there could be an issue which might require you to, maybe not run the instances locally, but then have some other shared infrastructure where you can run it. But again, that brings another possible roadblock that we have to work around. Okay, some examples of emulators that are using development. For example, these are normally emulators that will provide most of the functionality of a managed service. They tend to be custom programs, and again, they provide the functionality that looks very similar to a managed service that we don't have access to. And by managed service, I mostly mean cloud services. S3, DynamoDB, SNSQS from AWS, Cloud Spanner, Cloud PubSub from GCP, things like that, those kind of services that you cannot run the actual instance locally. There are some emulators that can provide very similar functionality that you can run locally. Of course, they also have their own issues. Limited functionality. Functionality tends to be significantly more limited than when you're running a local instance of an actual database. So for example, running the emulator for Cloud Spanner is going to have more limited functionality than the real Cloud Spanner. Whether if you're running a local MySQL, it tends to be a lot closer to the actual MySQL that you're going to have in production. Performance will not match the actual service. They have very different performance profiles, so we also have to be aware of that. Okay, another example of an emulator that can be used in development is an in-process database or service. Basically, inside of our own process, inside of our own application, we can start up our own instance of services like ActiveMQ, Neo4j, and some other external databases and services. Again, some issues with this, limited functionality. Normally, you're basically running the same code as would be running production, but there are some things that you might not be able to do, like replication, things like that. Because of the same reason, performance does not match the actual service. And you have very limited language availability. If we're talking about things like Neo4j and ActiveMQ, they only run in JVM-based applications. So if you're using something that is not JVM based, then you're out of luck and you cannot run your own ActiveMQ instance. You cannot run your own Neo4j instance. Okay. So, when we're using emulators, for example, if they are emulators that are running in an external process, as senior developers, we should take care to make sure that they're packaged in an easy to distribute manner so that other developers in our team can quickly get up to speed. If you can do it as a container, normally that tends to be the easiest way, assuming you can run Docker in your organization. We want to automate the setup and the teardown of the emulator as much as possible. This can be done inside of the container, inside of the automated build. We can use things like Docker Compose. If we have access to Kubernetes clusters, the whole thing can also be deployed in Kubernetes. It is really easy to set up and tear down just by passing some YAML files. For in-process emulators, you normally want to include them as a dependency. You want to ensure that the dependency is set to the right profile to make sure that we are not shipping emulators in the production code, things like that. So we have to determine when do we need the emulator. Do we need it only for building? Do we need it only for execution? Things like that. One of the advantages of in-process emulators is that we can write code to set up and tear down the emulator. We're developers, we write code to solve problems. This is a problem, we can write code to make this work. Now, let's talk about mocking missing APIs. When we rely on external APIs that are not ready, we can create mock implementations to keep our team productive. And here we're talking about APIs that are custom made, that are basically built by other teams in our organization. So there's no off-the-shelf emulator that we can use. There's no easy to install local instance that we can run. This is custom code that another team is building, but it is not ready yet. And we've identified that that is a possible risk to our development. So again, we can mock missing APIs. Now, the first question is, doesn't this create code that will be thrown away? And the answer is yes, or maybe not. Maybe we can use some of this for unit test. But the important thing is that regardless of whether this code is going to be thrown away or not, it will help us keep moving forward. Okay, let's say that we are going to depend on an API. That API is still in process. What is the minimum that we need to be able to mock a particular API? For example, do we have a data model already defined? Do we know what the request looks like? Do we know what the response looks like? Can we work with our peer team to solidify the data model up front? Can we agree on an API specification, protocol buffer specification, JSON schema, or maybe even a shared library with the object model already built, so that at least we have come to the agreement that this is what the data model looks like. This is what the API is going to expose. Sure, the API is still not fully implemented, but at least it will make it easier for us to mock the API and write code that will depend on that API whenever that API is ready. So, if we have that data model, makes things a lot easier. So, if we can agree on these contracts, the mocking will be closer to the final result. Because no matter how much effort we put, how much we coordinate with the teams, there's very high likelihood that when we write code against a mock API, we're going to have to tweak it once we have the real API. But the closer we get, the better. If we cannot agree on the contract, we can still go ahead. We'll have to rely on our own domain knowledge, the domain knowledge that is present within the team, to be able to figure out something close to what that API would look like. If we have to do that, make sure we're using proper object-oriented patterns. We want to program against interfaces. We also want to leverage the framework that you're using to make it easy to swap implementations as the APIs actually come available. So, make sure that you are, again, using best practices, keeping code abstracted, keeping those APIs that are problematic because they're not ready, make sure that they're properly abstracted so that we have a few entry points that we will have to modify to be able to keep moving forward. All right, now let's talk about creating an end-to-end test to help us move along faster. All right, something important is that code is only as good as the quality of its tests. Ease of testing must be ingrained in the code for us to say, hey, this is actually good, high quality code. And testing should be front and center. As we're designing an application, we should be thinking not only what the application is going to do, but how are we going to test that application? How are we going to test that service? One end-to-end test is better than zero, but two is not necessarily better, especially in the beginning. As we're starting to build up our, our new project, I personally recommend that you start creating a single end-to-end test that covers as much of the service as possible, but maybe not as deep as you would write, tests as you're getting close to the end of the development. But in the beginning, writing one end-to-end test that covers as much of the system as possible is going to give you a lot of value in validating the architecture that you've designed. One of the best ways to implement this is using the test message pattern. The test message pattern is from a very famous book, Enterprise Integration Patterns, and it's really relevant for this. So, we have a few components here. We have the test data generator. That one is on the bottom left corner. That one is going to generate test messages that are going to be sent to the component that we're building. We have a test message injector that is, it's going to allow us to take test messages, but it's also going to allow us to take actual messages, actual calls, actual requests, whatever, however your service is set up, is going to merge real messages, real request with the test message. It's going to send it to the processor. At the end, after the component, the application has processed what we've sent, we have a separator that is going to send the result of the test to a test data verifier. Now, once we have the result of the whole system running through, of the message running through the whole system, we can verify whether it worked properly or not. This is particularly useful for distributed systems where we have more than one processor, more than one component, more than one service. Being able to send a message throughout the whole system makes it really easy. Of course, to be able to do this, we need to take into account testing front and center. What does that mean? For example, for each test request, for each test message, we need to be able to indicate, hey, this is a test request, this is a test message. We can do that by adding a custom header, if we have control of the data model. If not, we can use things like magic or special values, but that's not recommended. So highly recommend that you take a look at test message patterns. I highly recommend that you take a quick look, a deep look at enterprise integration patterns in general, but this one is really relevant for the topic we're talking about today. Again, the value here, test message pattern would allow you to validate the architecture up front. It's going to allow you to test new changes as they're integrated. You can even use this to smoke test new releases. And then once you have that framework built, it's very easy to add more test cases, to add more detail, things like that as needed. So in this particular case, there is not wasted effort. So I want to give a big shout out to Gregor Hope and Bobby Wolf, hopefully I'm pronouncing the names right, authors of Enterprise Integration Patterns, great book, tons of really useful patterns. We just cover one here, but again, great reading, great reference. With that said, let's move on to the next step, integration. Really straightforward. As the missing dependencies become available, we exchange the mocks for the real implementations. If we can, we reuse the code that we have for the mocks, we use them for more testing. We expand our testing scenarios as we get more requirements, as we get more mature. And with this, we keep the team moving despite roadblocks that will undoubtedly appear on our journey. So just to summarize, we want to mock dependencies to make progress. That is the number one objective of creating these mocks. Some mocks will be removed as we make progress. Some of this work can be reused for testing. Some of it will be discarded, and that's okay. Now, with that said, if you'd enjoyed this video, follow me on the journey. The next video, we're going to talk about how to write effective unit tests, how to write easy to test code. All right, thanks for watching. Don't forget to subscribe, and you can also follow me on social media or hit up my webpage, www.javaprocess.com. Thank you.